Hi guys, it's been a long time not to see you. Will you be surprised if I said I miss you? I even miss the foolishness of the three guys in 9B. I'm sure you know who they are. Well, in this very limited condition, we still must do our best to accomplish our goals. I must give you a proper preparation for your final exam. I expect that you also prepare yourself for the upcoming exams. The following videos contain the materials for your final exams. Don't forget to do the assignment since it will be a very good practice for you. I promise you that the problem in the assignment will be one of the questions in the final exam, even though it will not be exactly the same. I took the problems from random years of past paper, so the numbers are not in order. Now let's begin from the first problem. This is our first problem. Figure 6.1 shows a cross-section through a swimming pool. 6a, a ray of monochromatic light from a lamp at the bottom of the pool strikes the surface at A as shown. AI, state what is meant by monochromatic light. The meaning of monochromatic light is light of one wavelength or light of one color. From now on, it is a must to answer every question in full sentence unless the question just asks you to state the name or the value of something. You are not allowed to answer the questions in points. Please leave that habit behind. Later, when you join the IGCSE, you are expected to answer questions such as describe and explain in a paragraph. Leave the mark scheme style behind. You are not an 8th grader anymore. Now let's continue to the next question. Question 6a, double I. The water in the swimming pool has a refractive index of 1.33. Using information from figure 6.1, calculate the angle of refraction at A. The correct formula to calculate the angle of refraction according to Snell's law is N2 over N1 equal to sin I over sin R. N2 is the refractive index of the second medium. N1 is the refractive index of the first medium. I is the angle of incidence. And R is the angle of refraction. To know which one is N2, which one is N1, which one is I, and which one is R, we have to go back to figure 6.1. From figure 6.1, we can see that the angle of incidence at A equals to 40 degrees. Remember, the angle of incidence is measured from normal, this is the normal, to the incident ray. The light comes from the water to the air. Then the first medium is the water, while the second medium is the air. So N2 is the refractive index of air, which equals to 1, while N1 is the refractive index of water, which equals to 1.33. It is stated in the problem. You must memorize that the refractive index of air equals to 1. Now let's put the values of the refractive indexes into the equation. We will have 1 over 1.33 equals to sine 40 degrees. Remember, the angle of incidence at A is 40 degrees over sine R. This is the refractive index of air. This is the refractive index of water. Once again, the light comes from water to air. So this is the first medium and this is the second medium. Now we have sine R equals to 1.33 times sine 40 degrees. To get the equation, you have to do the cross multiplication. So sine R equals to 0.855. R equals to inverse of sine 0.855. This equals to 59 degrees. This is a round off number. So the angle of refraction equals to 59 degrees. Question A, triple I. On figure 6.1, draw the refracted ray. To draw the refracted ray, we have to go back to figure 6.1. Use your protractor to measure the angle of refraction. From the previous calculation on question 6A we get the angle of refraction at A equals to 59 degrees. So you have to measure the angle of refraction from the normal here, 59 degrees to the right. Or you can also measure from the zero mark of your protractor 31 degrees up. Why? Because the angle between the normal and the zero mark on your protractor is 90 degrees. So if this angle is 59, then the rest of the angle is 90 minus 59, which is 31 degrees. Mark the position of the 59 degrees. Then draw the line from point A, passes through the mark. You will get this line as the path of the refracted ray. This angle is 59 degrees. If you measure from the zero mark of your protractor, then this one should be 31 degrees. Question 6b. The critical angle for the water-air surface is 48.8 degrees. Another ray of monochromatic light from the lamp strikes the surface at B as shown in figure 6.1. BI, state and explain what happens to the ray after reaching B. To know what happens to the ray after reaching B, we have to go back to figure 6.1. Here, we can see that at B, the angle of incidence equals to 50 degrees. Once again, the angle of incidence at B equals to 50 degrees. Now let's compare the angle of incidence at B with the critical angle. The critical angle at B is 48.8 degrees. So now we know that the angle of incidence at B, which is 50 degrees, is larger than the critical angle, which is 48.8 degrees. So this what will happen. Total internal reflection occurs because the angle of incidence, which is 50 degrees, is larger than the critical angle, which is 48.8 degrees. BII. On figure 6.1, draw this ray. To draw this ray, once again we have to go back to figure 6.1. When total internal reflection occurs, no ray of light will emerge from the water. Instead, the ray will be reflected back into the water at B with the angle of reflection equals to the angle of incidence. In this problem, the angle of incidence is 50 degrees, this one. That means the angle of reflection is also 50 degrees. So now, use your protractor, measure the angle of 50 degrees from the normal or 40 degrees from the zero mark of your protractor. Then, you will get this line as the path of the reflected ray. This angle is the angle of reflection, which is 50 degrees, equal to the angle of incidence.